Hi grade 12s and welcome. In this video we're going to learn about these following topics in trigonometry, which is cast diagrams and reduction angles, area of triangle, sectors and segments, sine and cosine rule, sum and difference formula double, and half angles. So let us get straight into the first topic, which is a cast diagram. So how do we reduce angles using the cast diagram? So first we learn about coterminal angles. What are coterminal angles? Suppose that we have an angle which is 315 degrees. Other methods to represent this angle will be, obviously, if you're going in the anti-clockwise direction, starting from the x-axis, you always start from the x-axis and just touch the where the angle ends, in other words where the radius line ends. So this is 350 degrees, so we can represent this by 315 degrees. Now suppose you are ending off there. Now I can also end off at the same point by going right around, okay, and I can go multiple times right around to end up at the same point. That's the reason why we write 360 degrees k. Now what is k? K are basically integer values. So if the value of k is basically positive, then you are going in the anti-clockwise direction, and if the value of k is negative, you are going in the opposite direction, okay, you're going in clockwise direction. So if k is greater than 0, then we're going in the anti-clockwise direction, and if k is less than 0, then you're going in the clockwise direction, in other words this direction here. Putting an arrow, anti-clockwise is the reverse, right? So I hope you guys understood that. Now let's look at two coterminal angles that we can look at. So another way to represent 315 degrees is I can choose a value of k which is negative, so negative 360 plus 15. So in other words, this angle over here will just be negative 45, okay, or another way to represent this angle will be 315 plus 360. In other words, the angle was 315, so if I go right around, okay, if I add a revolution, I will have 315 plus 360 degrees, so that is 675 degrees. Now remember, there are infinite angles like this. You can also choose a value of k as 2 and so on, right? So I hope you understood that. So this is basically like a general solution, all right, just adding revolutions and subtracting revolutions, that's it. Moving on, now we want to use cast diagrams to reduce 0 degrees, 180 degrees, or 360 degrees. So what is a cast diagrams? Cast diagram is built in this form, where we have the quadrants, and we are only looking at, that's a 0 degree line, right? This is the 180 line, right? And then back to here, this is also the 360 line, right? So it's either 0 or 360. If you go above 360, so that's 360 plus theta. If you, this angle over here in the second quadrant, remember these are quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you go before 180, that's 180 minus theta. If you go after 180, that's 180 plus theta, and if you go before 360, that's 360 minus theta. So we're going to just highlight these because those angles are important. Right, and we know this is the diagram for cast, C-A-S-T. The first quadrant represents all the angles, all the trigonometric ratios are positive. In the second quadrant, sine and cosec are positive, the reciprocal of sine. In the third quadrant, tan and cot are positive. In the fourth quadrant, cos and sec, the reciprocal, those are positives. So now when you are reducing using angles like 0, 180 and 360 is basically horizontal reduction. Okay, so if I want to reduce something like this, what is sine, these are examples, sine of 180 degrees minus theta. So we locate where is 180 degrees minus theta. That's in the second quadrant, and in the second quadrant we can see we have located it, sine is positive, so it's just going to be positive sine theta. Okay, if we want to find what is sine of 180 plus theta, this 180 plus theta will be in the third quadrant, but sine is not there. So in other words, sine is negative, right? Only tan and cot are positive, so negative sine theta. Next one, if we want to reduce cot of theta minus 180. Now what is cot of theta minus 180? Remember, because the angle is negative, we're going to make it a positive angle, so we're going to add a 360 in here. If we add 360, what is 360 minus 180? It is 180, so cot of 180, and remember the theta remains positive, we're not changing that. So we want to make it look like 180 plus 180 minus 360. So if we simplify this, that's in the third quadrant, and cot is positive, so it's just cot theta, and you know cot theta is cos theta over sine theta. I hope you guys understood that. Now what do we do when we have 90 and 270? What happens when we have 90 and 270? So a similar thing happens like this, right? So 90 and 270, 90 degrees is here and 270 degrees there, right? When we have 90 and 270, how do we reduce? So this is 90 minus theta, that's 90 plus theta, second quadrant, as a theta angle, that's 270 minus theta, and this is 270 plus theta, which is the fourth quadrant. So quadrant 1, quadrant 2, quadrant 3. Quadrants are usually represented with the Roman numerals, and the last one is quadrant 4, right, IV. Now this is still cast. This is supposed to be 270 plus theta, yes. Remember, this is still the cast diagram, C A S T. Now these are, remember, sine and cosec, right? Sine and CSC, cosec, tan and cot, this is cos and sec, reciprocals, and all are positive in the first quadrant. Now when we are using 90 and 270, it takes co-ratio. Examples, cos becomes sine. Remember, the full form of cos is cosine. So it has a cosine, sine, and sine becomes cosine if you are using 90 and 270 to reduce. Similarly, cosec becomes sec, right, and sec becomes cosec. Similarly, cot becomes tan, right, and tan becomes cot. So let's take a few examples. So if I ask you what is tan of 270 plus theta, 270 plus theta is basically in the fourth quadrant, and tan is negative. Now because of the 270 we are using as an angle, it changes to co-ratio, so tan changes to cot. So that's it, the answer is cot theta. Taking another example, what is sine of 90 minus theta? 90 minus theta is in the first quadrant, so sine is positive, so positive, and because of the 90 changes to co-ratio, which is cos theta, positive cos theta. Taking another example, what is cosec? Cosec, what is cosec? Let's take any one from here or something different. Negative theta, negative 90, right? If I have cosec negative theta negative 90, we can see the angle is negative, So we're going to add a 360 in here, right, and make it look like one of our cast diagram angles. So that becomes cosec 360 minus 90 is 270 minus theta. Now 270 minus theta is in the third quadrant, and cosec is negative, so it becomes negative sec theta. I hope you guys understood that. Remember, sometimes the angles we can change. Remember 90 degrees, remember 90 degrees is basically pi radians, pi by 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi by 2 radians. Okay, so that's from degrees to radians, and 2 pi is basically 360 degrees is 2 pi radians, right? So these are degree angles and those are radian angles, right? So I hope you guys are understanding. Now let's solve some problems. Find the value of tan 330. Tan of 330 is basically in the we're doing general examples now, so try to use 180 as far as possible. So this is tan of 360 minus 30 degrees. Now this is in the fourth quadrant, and tan is negative in the fourth quadrant, quadrant 1 2 3 4. So tan is negative in the fourth quadrant, so tan of 30, because remember 360 we are reducing, that's why it's called reduction angle. Now tan of 30 is we're using the 30 60 90 triangle. There's 30, sine of 30 is half root 3. Tan of 30 is 1 over root 3. So my answer is negative 1 over root 3. Rationalizing this, multiplying by root 3 over root 3 will give you calculate the answer, which is negative root 3 over 3, because root 3 times root 3 is 3. I hope you guys understood that. Now typing this into the calculator, you will see you get the exact same answer. So I'm going to type tan 330. Remember, your calculator needs to be on degree mode. See, it's on radians now. You get an incorrect answer. So shift mode and go back to degrees, which is 3. And now tan of 330 is negative root 3 over 3. Next question. Write down two coterminal angles for 400 degrees. So now remember 400 degrees. I'm going to represent it. What's 400 degrees? So I'm going to draw a line. 400 degrees is basically 360 plus 40, right? So here's my angle, that's 360 plus 40 degrees, right? That's 400. That's my angle 400. So the other angle is called this theta. So theta is equal to, I can go just from the x-axis to there, which is just 40 degrees, right? And another angle that I can find is going in the opposite direction, in the clockwise direction. So 360 minus 40, which is negative 320. Or you can use the formula, which is theta equals 400 degrees plus 360k. You can clearly see when the value of k is negative 1, you're getting 400 minus 360, which is 40 degrees. When the value of k is negative 2, I will get negative 320. Let's check this out. So I need to say 400 minus 400 plus 360 times negative 2. So I'm getting negative 320. I hope you guys are understanding. Moving on to the next question. Remember, you need to know special angles as well. Simplify sine 570. We just want to simplify 570. So 570 will be, take away a revolution from here, minus 360, right? So 071, you're going to get 210. Now 210 is in the cast diagram, so that's in the third quadrant. How you know that? Because that is 180 plus 30. 180 plus 30 is 210. So, and sine is negative in the third quadrant, so that becomes negative sine 30 and using your 30, 60, 90 triangle, you're going to get negative half. Sine of 30 is half. This is basics. Find sine theta if theta equals negative 120. So sine of negative 120. Let's add a revolution here. We're going to add 360 because the angle is negative. So we will get sine 240, and 240 is in the third quadrant. How we know that? Because that is sine 180 plus 60 degrees, right? Which is basically negative sine 60. How we know that? Because third quadrant sine is negative. Look here, third quadrant sine is negative. And using your 30, 60, 90 triangle, you're going to get negative sine of 60 is root 3 over 2. And that's my answer. Moving on to the next question. In which quadrant does the terminal arm of the angle theta lie? In other words, what's the terminal arm? These are terminal arms, right? So we're going to look at this, how to solve. So sine theta is less than 0, so cast, right? Where is sine negative? Less than 0 means negative. So where is sine negative? Sine is negative in the third and fourth quadrant, because first quadrant all is positive, second quadrant sine is positive. Where is tan positive? Tan is positive in the third and the first. So most amount of information here simultaneously occurs in the third quadrant. So this is the third quadrant. So third quadrant. Where is sine positive and cos negative? So again, cast diagram. Now remember, if you're drawing a terminal arm in the third quadrant, the angle will be like this. That's theta angle, right? Now where sine positive and cos positive? Sine is positive in first and second, cos is positive in the fourth and first. So the terminal arm lies in the first quadrant. There's your angle theta there. So quadrant, just write first quadrant. So this here is the first quadrant. Where is cos negative? Cast diagram again. Cos is negative in the third and second quadrant. Where is 0 to 180? 0 to 180 covers all the angles in the first and second quadrant, first quadrant and second quadrant. So the terminal arm is now in the second quadrant. There's your angle theta there, right? So this is the answer, second quadrant. I hope you guys are understanding. Moving on to the next question. Given cos theta is negative 4 over 5 and theta is between 0 and 180, find the value of tan theta. First, we have to go and locate which quadrant this diagram has to be in. So cast a diagram, right? Now first, where is cos negative? Third and second and third. Where is 0 to 180? First and second. So my diagram is now basically in the second quadrant. Now we know that cos theta negative 4 over 5, so adjacent, hypotenuse, that's the angle theta, and the opposite will be 3, 4, 5 triangle, Pythagorean triples. So what's the value of tan theta? So tan theta is now equal to opposite over adjacent. Opposite is 3 and adjacent is negative 4. So 3 over negative 4 is the same thing as saying minus 3 over 4. So you have to draw a diagram to solve tan theta. I hope you guys are understanding. Next one, we want to simplify this. So what I'm going to do is simplify each one and then put everything together. So first we'll find sine 120. Sine 120 is sine, where's 120? Second quadrant, right? So that's 180 minus 60. 180 minus 60 is 120, alright? So nothing changed here. I just changed the form so you can locate the quadrant. Second quadrant sine is positive, so we're getting sine 60, and we know what is sine 60. That is root 3 over 2. So that is root 3 over 2. What is cos 210? Cos of 210 is cos 180 plus 30 degrees. Now 180 plus 30 is in the third quadrant. You have to use 180 and 360 to simplify these numbers. So this is in third quadrant, cos is negative, so we're getting negative cos 30, Now cos of 30 is root 3 over 2 again, so but negative. Now we're simplifying the next one. Tan 315. Tan 315 is basically equal to tan 360 minus 45 degrees, right? That's how you get 315, which is basically in the fourth quadrant, and tan is negative, so we're getting negative tan 45, and we know tan of 45 is 1, so negative 1. Next one, we want to simplify cos 27. Cos of 27 is basically, you can use co-ratio, is the same thing as saying cos of 90 minus something will give you 27, which is basically 63, right? I didn't change anything here. Cos of 27 is cos of 90 minus 63, which is basically cos of 90 minus 63. We are using 90 degrees now, and it's in the first quadrant, so cos is positive, and it changes to sine, so sine 63. Right, so great, we have everything on top. Now sine 63, we're not going to change that because we already have cos 27 and sine 63 cancelling out. We're going to do the last one, which is cos 540. Cos of 540, we're going to take out one revolution, so that is cos of 540 minus 360, which is cos of 180. Take cos of 180, you can either add a 0 or minus a 0, it doesn't matter. So let's just add 0. So we can say this is basically in the third quadrant or in the second quadrant, basically on the line. So cos is negative in the third and in the second quadrant, so either is negative cos 0, and cos of 0 is 1, so negative 1. So now my answer is basically equal to each of these, root 3 over 2 times negative root 3 over 2 times negative 1 times cos 27 all over sine 63 dot cos of 540 is negative 1. Okay, now we can see everything cancelling out. We can see 63, 27 cancel out, negative 1 cancels out. So we got root 3 times root 3, which is, remember there's still a negative there, so negative 3, and 2 times 2, which is 4. So my final answer is negative 3 over 4. Hope you guys understood that. Now similarly we will also simplify this. What is sine of pi by 2 minus x? Sine pi by 2 minus x is 90. 90 minus x, it changes to cos x because co-ratio, times what is cos of pi plus x? That's in third quadrant, and cos is negative, so we're getting negative cos x. It does not change your co-ratio because we are using 180. Plus what is tan sine x over cos x, right, times cos x, times the only thing that I will do additional work for is sine x minus pi, right? So I'll write this down, sine of x minus pi. I'm going to add a revolution here, so add 2 pi. I will get sine 2 pi minus pi is pi plus x, right? And that is in the third quadrant, sine is negative, so negative sine x, so times negative sine x. Now I've got cos x times cos x, which is negative cos squared x. Negative times positive is negative, and cos cancel out. We got negative sine squared x. I can take out a negative 1, so I'm left with cos squared x plus sine squared x, and I know cos squared plus sine squared is 1, so my final answer is negative 1. I hope you guys are understanding. Moving on to the next question. We are given a point P, which is 8 and negative 15. That should be a negative 15 because it's in the third quadrant, right? So I'm going to bring this down, right? 8 and negative 15. Okay, so it's in the third quadrant. X value and y values are both positive, so this is negative 8, and coming down is negative 15, So what's the radius? Using Pythagoras you can get 17, or you can use the Pythagorean triples, 8, 15, 17. 8 squared plus 15 squared is 17 squared. So we want to find what's the value of, not tan theta, let's find what's the value of cos theta. Actually we need to find, let's find each one. Sin theta, and let's find what's the value of tan theta as well. So what is cos theta? Adjacent over hypotenuse, so minus 8 over 17. Sin theta is negative 15 over 17, and tan theta is opposite over adjacent, negative 15 over negative 8, which is 15 over 8. I hope you guys understood everything.